Hello students, welcome to my YouTube channel. In this video lecture, I am going to solve questions from sample paper 6. So far I have solved question 1 to question number 95. In this video lecture, I am going to solve the last 5 questions, question 96 to question 100. So let's begin with question number 96, easy. So there is one coordinate, Papa, 28 degree 24 minutes south, 21 degree 16 minutes east. Over this latitude, over this position, you are at 4,000 feet, climbing to flight level 260. Mean rectified airspeed 150, rate of climb 650 feet per minute, heading 267, temperature minus 7 degrees Celsius. Climb velocity and climb wind velocity is 140 at 30. You have to find your new position at the end of your climb, that is at the end of your top of climb, right? So let's plot this position given to us first. We have been given 28 degree 24 minutes south. So 28 degree 24 minutes south, 21 degree 16 minutes east, right? Let's say this is that position. So now anything to let's consider this your north datum. This becomes your 270 direction, westerly direction. Next. Now from this position at 4,000 feet, your heading is 267. Your heading is 267. 267 heading means southwesterly heading. We have to find out the end position, the final position we will be at after the climb is complete. Now here three options are given. 28 degrees south, 20 degree east, 28 degree 52 minutes south, 19 degree 10 minutes east, 27 degree 22 minutes south, 19 degree 46 minutes east. So let's plot all these three positions. So we have 20 degree east, 20 degree east, we have 19 degree 10 minutes east and 19 degree 46 minutes east. So 20 degree east will be, let's say, somewhere here. The closest longitude to the longitude 21 degree 16 minutes east. So that is 20 degree east. The next closest will be 19 degree 46 minutes east. So let's say this is that longitude, 19 degree 46 minutes east. The third and the last, 19 degree 10 minutes east. Minutes east longitude. Now the positions, latitude positions, 28 degrees south, 28 degrees south. Now 28 degrees south will be to the north of 28 degree 24 minutes south, to the north of that latitude, because we are in the southern hemisphere. So 28 degrees south is, let's say, here. Next, 28 degree 52 minutes south. 28 degree 52 minutes south will be to the south of 28 degree 24 minutes south. Okay, to the south of that. So it will be somewhere here. Because it is more in value than 28 degree 24 minutes south. At the last latitude, 27 degree 22 minutes will be further north of 28 degree 24 minutes south and 28 degrees south. So 27 degree 22 minutes south is this. Now out of these three positions, we have to determine one position at which this aircraft will be over after the end of its climb. Following a heading of 267, which is to the southwest of heading 270. Only possibility, heading 267. The only possibility that there is, you will end up being over latitude 28 degree 52 minutes south, because that is the only latitude only position which is to the southwest of, the southwest of westerly direction, or to the southwest of this position. Other positions, 28 degrees south and 27 degree 22 minutes south, are to the northwest of that position. So we are not flying a northwest heading. If we do not fly a northwest heading, there is rare possibility or there is impossibility of us or of our going towards that direction, right? So we will not end up being any of these locations here. We will end up being over this location, 28 degree 52 minutes south, 19 degree 10 minutes east. So the correct option is option Bravo. Next, question number 98. Positions X and Y are 960 nautical miles apart. At 12 o'clock 5 minutes, aircraft A leaves position X en route to position Y at a ground speed of 370 knots. 20 minutes later, at 12 hours 25 minutes, aircraft Bravo leaves position Y en route to X at another speed of 290 knots. At what time will they pass each other? So very important question. So here is, let's say, position X, position Y, this is XY. The total distance between them is 960 nautical miles apart. At 12 o'clock 5 minutes, aircraft A leaves position X. So at 12 o'clock 5 minutes, there is aircraft starting from this position X. 20 minutes later, it will be somewhere here. Let's say it will be here. At 12 o'clock 25 minutes, it will be somewhere here. And at the same time, 12 o'clock 25 minutes, there is another aircraft originating from point Y, traveling towards position X. So out of this total 960 nautical miles, we will subtract this much distance that aircraft beginning from X has covered. So the time here is 20 minutes. The speed of this aircraft 1 is 370 knots. So the distance that it covers will be 370 into 20 divided by 60, that is 123 nautical miles. So the distance will be 123 nautical miles. So the distance left between these two aircraft will be 960 minus 123, which is 837. So I'm erasing this, or I will draw a new point. Now we will draw a new diagram. So starting from this position, that is at 12 o'clock 12:25 to here. So the position is 837 nautical miles. 12:25 12:25. Now we have to find the distance or the position, or that, yes, we have to find the time when this both aircraft will cross each other or pass each other. So there are three times given to us, three timings: 13 hours 21 minutes, 13 hours 41 minutes, and 13 hours 43 minutes. So what we will do is we will check every option given to us. Now let's consider option A, 13 hours 21 minutes. Okay, option A is 13 hours 21 minutes, right? Now 13 hours 21 minutes minus 12 hours 25 minutes is 56 minutes. Now the ground speed of this particular aircraft is 370 knots. That means it covers 370 nautical miles in 1 hour. 1 hour means 60 minutes. So 370 nautical miles in 60 minutes. That means in 1 minute it will cover 370 divided by 60, 6 nautical miles per minute, right? Now aircraft, the second aircraft has a ground speed of 290 knots. Has a ground speed of 290 knots. That means it covers 290 nautical miles every 60 minutes. So in 1 minute it will cover 290 divided by 60, 5 nautical miles in 1 per minute or 1 minute. Now here the timing is 56 minutes. From 12:25 to 13:21, the elapsed time is equal to 56 minutes. So in this 56 minutes, this aircraft number 1 will have covered in 56 minutes. The distance will be equal to speed into time. Speed is what? 6 nautical mile per minute. So 6 and time is 56 minutes. So 6 into 56 is 336 nautical miles. And the second aircraft will have covered a distance of 5 into 56, 280 nautical miles. So let's say, so 837 minus 336 is 501. Okay, so so this aircraft will have traveled from this distance to, let's say, over here, somewhere here, covering a total distance of 336 nautical miles. Now the remaining distance will be 501 nautical miles. 837 minus 336. Out of that 501 nautical mile, the distance covered by the second aircraft is 280 nautical miles. So beginning from here, this aircraft will have traveled this much, 280 nautical miles. 336 nautical mile, 280 nautical mile. The remaining distance is 280 plus 336 is equal to 616 minus 837 is 221. That means still there is a distance of 221 nautical miles between the positions of this and this aircraft. So that means option A is the wrong option. At 13 hours 21 minutes, this two aircraft won't pass each other because there is still so much distance left between them. Now let's check option number 2. I will take a second slide, a new slide. So option number 2. Option number 2 is 13 hours 41 minutes. Option number Bravo is 13 hours 41 minutes. Now 13 hours 41 minutes minus 12 hours 25 minutes. So we are going to again draw the same diagram. There is this aircraft number 1. There is another aircraft directly in front of it. Now both are going to start flying at the same time, 12 hours 25 minutes. 12 hours 25 minutes. This distance between them is equal to 837 nautical miles. The speed of aircraft number 1 is 6 nautical mile per minute. The speed of the second aircraft is 5 nautical miles per minute. Now 13 hours 41 minutes minus 12 hours 25 minutes is equal to 1 hour 16 minutes. That is equal to 76 minutes. Now in this 76 minutes, aircraft number 1 will have traveled a total distance of 6 into 76, 456 nautical miles. And this aircraft number 2 will have traveled a total distance of 5 into 76, 380 nautical miles. Correct? So let's draw this. So from this position to this position, distance traveled is equal to 456. and the second aircraft will have traveled a distance of 380 nautical miles. Now the distance, now total distance is 456 plus 380, 36, 836. That means I will have to draw this somewhere here. So the distance is 380. Now total distance. Now the distance traveled. So total distance traveled is by both this aircraft is equal to 456 plus 380. That amounts to 836 nautical miles. Now we know that the total distance separating this aircraft, these two aircraft, is 837 from the beginning, right? And now after traveling 76 minutes each, they have crossed a total distance of 836 nautical miles, which is almost equal to 837 nautical miles. That means option Bravo is the correct option. At 13 hours 41 minutes, both aircraft will pass each other or will be very close to passing each other. Okay, so the correct option is option Bravo. Okay, so the total distance is 837. This has traveled 456. Another aircraft, the other aircraft has traveled 380. So both have done their duties and now they will be passing very close to each other. Just for understanding, let's consider option number Charlie. Option number Charlie states time 13 hours 43 minutes minus 12 hours 25 minutes. So that means there is this aircraft number 1. There is another aircraft directly in front of it. Okay, both are separated by a distance of 87 nautical miles. Starting time 12:25. Starting time 12:25. Ground speed of this aircraft 6 nautical miles per minute. Ground speed of this aircraft 5 nautical miles per minute. The time difference between 12 hours 25 minutes and 13 hours 43 minutes is 1 hour 18 minutes. That is equal to 78 minutes. Now in this 78 minutes, aircraft 1 will travel a distance of 6 into 78, 468 nautical miles. Second aircraft will travel this distance of 5 into 78, 390 nautical miles. Now the total between these two distances is, the total of these two distances is 468 plus 390, 858 nautical miles. 858 nautical miles. 468 plus 390, 858. So that means 6 into 78, 368, 5 into 70. So that means this two aircraft will have passed each other. So that means this aircraft will be somewhere here. Okay. Second aircraft will be somewhere here after crossing a distance of 390 nautical miles, and this first aircraft will be somewhere here after crossing a distance of 68 nautical miles. So that means both this aircraft will be very well past each other. Okay, not passing each other but very well already past each other. So correct option here will be option Bravo. 13 hours 41 minutes. Because we have been asked to find out the time, this aircraft will pass each other. Okay, so if at 13 hours 21 minutes both these aircraft are still very far away from each other, as indicated here by 221 miles, Option Bravo 13 hours 41 minutes. In this case, both these aircraft are very close to passing each other. Option number Charlie, both these aircraft will have completed passing each other. So the most appropriate option will be option Bravo. Next, question 99. A chart is given to you. The scale is given to you. The distance between 2 points is 30 centimeters. So chart distance is 30 centimeter. Scale of this chart is 1 divided by 1, that is 10 lakh. The time taken between these fixes is 45 minutes. What is the ground speed of aircraft? Now using the scale formula, we will first find earth distance. Step 1. Step 2. When we know earth distance, when we have time given to us, we can calculate ground speed using speed distance time formula. So scale equals to, write the formula, chart distance divided by earth distance. Therefore, earth distance will be chart distance divided by scale. Chart distance is 30 centimeter. Scale is 1 divided by 10 lakh. So that will be equal to 30 centimeter into 10. So earth distance will be equal to 30 into 1, 2, 3, 1, 2, 3. That is 30 so many centimeter. Now convert this centimeter into corresponding nautical mile. We know that 1 nautical mile equals to 1852 meter, right? And 1 meter equals to 100 centimeter. Okay, multiply by 100. So now we have to convert this so many centimeters back to nautical miles. So 3 into 136, 3 into 10 raised to 7 equals to how many centimeters? So earth distance will be cross multiply 3 into 10 raised to 7 centimeter divided by 1852 into 10 raised to 2. So earth distance will be 10 raised to 5. 3 divided by 1852 is 1.6198 something. So 1.6. So 1.6 into 10 raised to minus 3. So earth distance is 1.6 into 10 raised to 2. So earth distance will be equal to 160 nautical miles. Now if earth distance is 160 nautical mile, time taken is 45 minutes. Ground speed of this aircraft will be distance divided by time, 160 into 60 divided by 45 minutes. Convert those 45 minutes into hours. So 160 into 60 divided by 45 is 213 knots. So the closest option, so 213 knots, that is 213 nautical miles per hour. Now you want to convert this into kilometers per hour. So what you will do is speed, that is 213 knots, will be equal to 213 into 1.85 nautical miles per hour. So 213 into 1.85 will be 394 nautical mile, 394 kilometer per hour. So the closest option here will be option Charlie. The closest option here will be option Charlie. 99 is C. That is 400 kilometer per hour. 400 kilometers per hour. 394 kilometer per hour. That is 400 kilometers per hour. Next. Last question, question 100. Aircraft departs from position X at 9 o'clock. It goes easterly at a speed of 455. At 15° west, okay, it flies due north at a speed of 422 knots. What is the estimated time of arrival? A beam means parallel when you are parallel to a position of y, which is at 13 degree 45 minutes west. So let's draw these three different longitudes: 34 degree 15 minutes, 34 degree 15 minutes west, 15 degree west, and 13 degree 45 minutes west. Okay. Next, first position is 27 degree 34 minutes south. 27 degree 34 minutes south. Flying 90 degree. Okay, aircraft flies a heading of 090, and then after reaching 15 degree west longitude here, it decides to fly north. It starts flying northerly direction somewhere here. And there is another position 19 degree 35 minutes south, 19 degree 35 minutes south. So we have to find the time at this position, time when aircraft reaches this position, and this position is parallel to directly a beam this particular position. So the ETA a beam of y. So the starting time is 9 o'clock. The starting time is 9 o'clock. Distance that this aircraft will cover beginning from this longitude to this longitude will be equal to Rumline distance of d long in minutes into cos lat. Now the difference between these two longitudes is 34 degree 15 minutes minus 15 degree 19 degree 15 minutes into 60 into cos of latitude, that is 27 degree 34 minutes. So 19 degree 15 minutes into 60 into cos 27 degree 34 minutes is equal to 1000. So correction, cos 27 degree 34 minutes into 60 into 19 degree 15 minutes is 1023. 1023 nautical miles. Ground speed of this aircraft is 455 knots. So the time taken will be distance divided by speed. 1023 divided by 455. 2 hours 14 minutes. 2 hours 14 minutes. That means the time when this aircraft will be at this position will be 09 hours plus 2 hours 14 minutes. So that means aircraft will reach this position 2 hours 14 minutes after 9 o'clock. So 9 plus 2 hours, that is 11 hours 14 minutes. Now at 11 hours 14 minutes, it changes its direction from easterly to northerly, and it travels a distance. It flies due north at a new speed of 422 knots. At a new speed of 422 knots. Distance. Now this distance is nothing but your great circle distance of d lat into 60. The latitudes, the two latitudes here are this latitude 27 degree 34 minutes south latitude, and this particular latitude which is 19 degree 35 minutes south latitude. So the difference between them, 27 degree 34 minutes minus 19 degree 35 minutes, is 7 degree 59 minutes, or approximately 8 degree. So that is equal to 480 nautical miles. Now the time taken to travel will be distance by speed, that is 480 divided by 422, 1 hour 8 minutes. So the time taken will be another 1 hour 8 minutes. So the time at which this aircraft will reach this position will be 11 hours 14 minutes plus 1 hour 8 minutes is 12 hours 22 minutes. So at 12 hours 22 minutes, this aircraft will be at this new position. So the correct option here will be option A, the closest option, 12 hour 23 minutes. 12 hour 23 minutes. Simple. So next. This concludes our lecture. I hope you have understood all the questions that I have solved, explained and elaborated. Practice these questions many times, and practice many times and then other times without looking for answers. Do it on your own. Set a timer and draw the diagrams and solve this particular question. Try solving this question in the shortest way possible. In this particular lecture, I have explained each and everything. I have drawn every diagram. I have labeled those diagrams in detail. But in exam, don't do this. Don't follow this technique. In exam, just do follow shortcuts. Do the steps, but follow some shortcuts. Don't spend much of your time in drawing, labeling. Okay. So for that proficiency to achieve that proficiency, you must be practicing these questions many times. So over a period of time, you will naturally develop this talent and ability to look at the question and then do or solve that question, at least 50% of that question in your mind. The remaining 50% you can, the calculations part, the drawing part, you can do it on your paper. Okay, and that way you have to help yourself and save time and get the right answers quickly. So that comes with practice. So keep practicing. Nothing is impossible. All the best. I should request you all to share this video with your friends and subscribe to this channel if you haven't yet. Hit the like button if you have liked this video lecture. Thank you for your time.